Imagine a place where gravity is so powerful that even light cannot escape. A place where time slows almost to a stop. Where space itself is stretched and twisted. And where everything we know about physics begins to break down. This isn't science fiction. These mysterious objects really exist. They're called black holes. For decades, they were only mathematical predictions. Many scientists doubted they could even exist. Today, we have photographed one. We have heard them collide. And we know that almost every large galaxy including our own contains one at its center. But what exactly is a black hole? How is it born? What happens if you fall inside? Could it become a doorway to another universe? Or, what is a black hole? Despite their name, black holes are not actually holes. They're incredibly dense objects created when an enormous amount of mass is squeezed into an unimaginably small region of space. According to Einstein's theory of general relativity, mass tells spacetime how to curve. And curved spacetime tells matter how to move. Normally, Earth bends spacetime only slightly. The Sun bends it much more. But when enough mass is compressed together, gravity becomes so strong that spacetime curves inward on itself. Eventually, there comes a point where escaping becomes impossible. Not even light, the fastest thing in the universe, can't escape. This invisible boundary is called the event horizon. Think of it like a waterfall in a river. Far upstream, you can still swim away. Closer to the edge, the current becomes stronger. Cross the waterfall, and no amount of swimming can bring you back. The event horizon works in a similar way. Outside it, escape is possible. Inside it, every possible path through spacetime leads inward. There is no turning back. To understand black holes, we first need to understand stars. Every star is a giant battle between two enormous forces. Gravity constantly pulls matter inward. Meanwhile, nuclear fusion pushes outward. Inside the Sun, hydrogen atoms fuse together into helium. This process releases enormous amounts of energy. That energy pushes outward, balancing gravity. As long as this balance continues, the star remains stable. But stars don't shine forever. Eventually, their hydrogen fuel begins to run out. Smaller stars, like our Sun, will expand into red giants, then gently shed their outer layers, leaving behind a white dwarf. But massive stars have a very different fate. If a star is more than roughly 20 times the mass of the Sun, its death becomes one of the most violent events in the universe. As hydrogen disappears, the star begins fusing heavier elements. Helium becomes carbon. Carbon becomes oxygen. Oxygen becomes neon. Then silicon. Until finally, the core becomes iron. And this changes everything. Iron cannot release energy through fusion. Instead, trying to fuse iron actually consumes energy. The star has reached the end of its life. Without enough outward pressure, gravity wins. The core collapses in less than a second. Matter falls inward at incredible speeds. Electrons combine with protons, forming neutrons. The collapse becomes so violent that the outer layers rebound outward. The star explodes. This is a supernova, one of the brightest explosions in the universe. For a short time, a single exploding star can outshine an entire galaxy. Heavy elements like gold, uranium, and platinum are created during these explosions. The atoms inside your body, and even the gold and jewelry, exist because ancient stars died billions of years ago. In a very real sense, we are made of stardust. After the supernova, what remains depends on the mass of the core. If it's relatively small, gravity is stopped by neutron pressure. A neutron star is born. Imagine squeezing more mass than our Sun into a sphere only about 20 kilometers across. Just 1 teaspoon of neutron star material would weigh billions of tons. But if the remaining core is even more massive, nothing can stop gravity. Not atoms. Not neutrons. Not any known force in nature. The collapse continues. Smaller, denser, until, according to Einstein's equations, an event horizon forms. At that exact moment, a black hole is born. From the outside, the star seems to disappear forever. Only its gravity remains. But inside, the story has only just begun. Because beyond the event horizon, the universe behaves in ways that challenge everything we think we know. To be continued.